Okay, our board work today, we're talking about deficient numbers. Deficient numbers. The ancient Greeks did this. The ancient Greeks thought about things. The ancient Greeks were really interesting because they weren't called mathematicians, they were called philosophers. What do philosophers do? They philosophize, they think. So mathematicians were actually thinkers. So they did things like they thought a number was deficient if the sum of its factors, excluding the number, was less than the number itself. And they talk about this. Okay? 8 is deficient because its factors, 2, 4, and 7. So, I'm looking at 36. If I factors 36, and to get prime factors, here's what I do. I write the number, I put a box, a half box under the number, and I look at all the potential prime factors of it. Well, it's even, so I know 2 goes into it. 2 goes into 3 once, with 1 left over. 2 goes into 16 8 times. So I know 2 goes into 36 18 times. Draw another box. 18 is even. 2 goes into 18 9 times. 3 goes into 9 3 times. 3 goes into 3 1 time. I know I've found all the prime factors. That's how to do prime factorization for any number. What the Greeks are talking about is, and from here you can find every single factor of a number. So the factors of 36 are 1. We know 2 goes in. 2 goes in 2 times 3 times 3, 18 times. 3 goes in 3 times 2 times 2, so 3 times 4, 12 times. 4, yes, 4 is a factor, and how many times does it go in? 9 times. Is 6 a factor? Yes, it goes in 6 times, and you've found all the factors. You see how the prime factors, you use the others, and there's the other side of it. Okay? So that's how you factor. You want to do another prime factorization and see how it works? Let's go to the other side, because I'll have more room. Let's use 50. What's a prime factor of 50? Yeah. Prime. 2, because it's even? How many 2's are in 50? Oh, is this deficient? If you add these numbers together, not including 36, is it deficient? If you add them together, is it less than 36? 18 plus 12 is 30, plus 9 is 39. Already, we're not deficient. So that's not a deficient number. So 2, how many 2's in 50? 2 and 5 is 2 with 1 left over. 2 and 10 is 5. You like the way? That's pretty easy, huh? What goes into 25? 5. How many times? 5. What goes into 5? 5. How many times? 1. You're done. All right? So, 1 and 50 go into 50. 2 and what? 2 and what's left? 5 times 5, which is 25. All right? 5 and what's left? 2 times 5, which is 10. Are there any other factors? No. So what's 25 plus 10 is 35, plus 5 is 40, 42, 43. That is deficient. Everybody see how to do it? Do you see how to factor? Get prime factors out of any number. And not have those leaves. Remember when we used to factor like this? Did we lose factors? Yeah, because they got kind of mixed up all over the place. Do you ever lose factors when you do it in this method? No, it's pretty cool. All right.